In this video we're going to be looking at sketching graphs, and our focus is going to be on sketching straight line graphs. So remember, in the last video we looked at finding the x and y intercepts of graphs. I'm going to just start by looking at 4 different scenarios on this first page. So starting with where you have y equals to just a number. Now it's important to realize that when you have that scenario, you land up with a horizontal line. So if y was equal to a positive number, it would be up here, and if y was equal to a negative number, you'd have a line down here. So that's our first case. Then our second case is where you have x equals a number. So x equals 2, x equals 1, minus a half, whatever. But in that specific case is where you have a vertical line. So if x was 1, you'd have a line on the right, and if x was minus 1, a line on the left. So those are my first 2 scenarios. Give ourselves some space here. The third case is where you have y equals something x. So there's no constant. Now in this case, it's important to realize that your graph is going to go through the origin. So we know my c value is 0, so it passes through the origin. If m is positive, it's going to go up to the right. If m is negative, it is going to go down to the right. So remember, up to the right is an increasing graph, down to the right is a decreasing graph. And we'll look at specific cases in a moment. Then the third type is where you either have your equation in standard form, where obviously you can tell what the gradient is and you can tell what the y-intercept is, or it's in the form where you have an x term plus a y term and then equals to a constant. You might find that sometimes the constant's on that side and you have it equal to 0. Either way, we're talking about the same thing. Now, in these 2 cases, you need to find your x and y intercept. So that, remember, we learned to do or revised how to do in the last video. So for these 2, you've got specific x and y intercepts that you need to find. So we're going to look at a couple of examples. Here's my first one. Y equals 3 and x equals negative 2. So remember what we said just now. When you have y equals to a constant, you're going to land up with a horizontal line. And when you have x equals to a constant, you're going to land up with a vertical line. So here we go. You can see what we have up here is the line y equals 3. Notice anywhere along this line, not just where it cuts the y-axis, but anywhere along this line, the y-coordinate will be 3. And then my line x equals minus 2 is this vertical line over here. So remember, horizontal line will be y equals to a constant, vertical line will be x equals a constant. Now, we need to show that those are horizontal or vertical by doing one of the following. Either put a right angle to show that they are perpendicular to the x or the y axis, whichever, or show that they are parallel to an axis. So only one or the other. It's not essential to have both. I usually prefer to use the perpendicular one. It's just easier. Okay, so the next type of graph I'm going to look at, you've got x plus y equals 4. Now remember from the previous video on finding x and y intercepts, you can find your x-intercept and your y-intercept by making y or x equal to 0. And on the last video, we saw that my y-intercept, we make x naught and we get y equals 4, so that was the point 0, 4. And to find your x-intercept, remember you made y naught and you got x was equal to 4, so that was the point 4, 0. Now what you need to do here is plot those 2 points and draw the line between them. Okay, so your y-intercept up there at 4, x-intercept at 4, and your line is drawn in between them. You'll see this graph has got a negative gradient, but you can't see it in the equation because the equation is not in standard form. But if we ask just to sketch the graph, that doesn't matter. We just need to find the x-intercept and the y-intercept. All right, so my next example We also found our x and y-intercept in the previous video, and my y-intercept, remember you made your x equal to 0, so my y-intercept was 0, negative 2. And my x-intercept was negative 6, 0. So all we have to do is plot those 2 points and draw the line between them. So there again, we can see my y-intercept of negative 2, my x-intercept of negative 6, and draw the line. Again, it's a decreasing graph. If you want a quick recap on reading off the gradient, remember you start at a point on the left, go across to a point on the right. If you've got your x and y intercepts, that's great. And that would be going down 2 and forward 6. So my gradient is negative, because it's going down 2 over 6, or a third. So that's just a different way, or you can put it into standard form. So that's just a little aside from our focus of sketching graphs. Okay, again, it's not in standard form, so you can't just look at it and say what the x and the y-intercept are, but we did find the x and the y-intercept in the previous video clip. So my y-intercept, remember you make x 0, and if x is 0, we're going to get that y is 2.5. And for my x-intercept, we made y 0, and we got x was negative 5. Now, it's not okay the way this picture looks. Yes, we've plotted a 2.5 on the y-axis, but we don't have it written there. And if you're doing this in a test or exam, you must write 2.5 next to your y-intercept. And you can see I can't see the negative 5 here. I need to make it very clear and label your x and y intercepts correctly. So make sure that you don't just cut through where you think 2.5 is, but actually label your graph properly. Okay, so you'll notice that this one's missing the constant. So you've got your x term, you've got your y term, but this is not what we saw in the previous few examples, and this is the case where you know your graph has to pass through the origin. Now that's a little tricky, but my hint is to plot your 0, so plot your origin, and then use the fact that your gradient is 2/3. So remember, gradient is rise over run, or your up-down movement over your forward movement. So we're going to start at the origin. We're going to go 2 up and then 3 forward. Okay, so that's going to give you the concept of your gradient. So when you look at the picture, watch out for that. So let's put that onto the picture. You can see the graphs, you know what it's going to look like. But remember, there's no constant over there, so we know it starts at the origin. Your gradient is 2 up, 3 forward. So if you go 2 up and you go 3 forward, you land up at that point there, 3, 2. Now, there's several methods you could use here. If you don't want to use that gradient method, then you can say, pick an x value. Now, a little hint over here. It's always a good idea to use an x value that will cancel with your denominator if you've got a fraction. So, for example, if we decided to pick x equals 3, then to work out the corresponding y value, you're going to substitute. Remember, it's 2/3 x, so 2/3 times 3, and that will give me 2. So in other words, when x is 3, y is 2, has to be a point on the graph. So remember, we knew that it was plus 0 over there, so the y-intercept was 0. And we chose our own x value, subbed it in, found the corresponding y value, which gave us this other point here. Oh, guess what? It's the same one that I got by doing my gradient. And remember, to draw a straight line, all you need is 2 points. So if I've got those 2 points, I can draw my line through. Okay, so a similar example, but this time things are looking a little tricky because I don't seem to have a fraction, and we know that gradient should be a fraction. But is that really as bad as I think it is? No, because any whole number can be written over 1 to give me the fraction. We know that there's plus 0, so again we know it's got to start at 0. my gradient says 3 down, 1 forward. So my graph's going to be quite steep, and so I'm going to translate that into the picture. Okay, so you can see my picture. So remember, it was plus 0, so we're going to start at 0. My gradient was minus 3 over 1, so I'm going to go down 3, forward 1, and you'll see I land up at the point 1, negative 3, and draw my lines through that point. Obviously, again, if you don't want to use your gradient method, you could just substitute in an x value. Now, there's no fraction in front of the x, so quite frankly, I can use absolutely any x value I like. So if I take it down here, you know, really easy peasy is to make x equals 1. So if x equals 1, I'm going to get y is equal to minus 3 times 1, which is obviously minus 3. So I get the point when x is 1, y is minus 3. Just, if you don't feel like using x is 1, you could have used x is 2. And if x is 2 and you sub it in, you're going to get y is equal to minus 3 times 2, which is minus 6. Now, obviously, in this case, that means I would have had to have made my y-axis extend further down. That's a bit of a pain, so I don't really want to worry with that. Okay. So we've gone through all the different types. What I would strongly recommend is that you start the video again, but each time you get to a new slide with an example, press pause before the picture comes up and before the explanation comes up. Draw a rough sketch on the side on a piece of paper, then restart the video and check that you've got it right. It really, really is important that you know how to draw a straight line graph.